Hi friends, I am developing this video based on Anna University ANSYS Practical Simulation Laboratory. With these videos, you can able to solve any type of problem using ANSYS Mechanical APL software. Now, we have an exercise called Truss Analysis. Perform structural analysis of a truss element as shown in the figure. Young's modulus value, Poisson ratio value and the areas are given. How we can solve this type of problem using ANSYS. First, open the ANSYS software, go to Preferences, select as Structural, press OK. Then go to Preprocessor, Element Type, Add, Edit, Delete, Add and select as Link. As it is a truss element, we have to select Link 3D Finite STN 180, press OK. Then close this dialog box. Then we have to give the area of the cross section. For that, go to Real Constants, Add, Edit, Delete, Add. It will show the link what you have chosen before. Press OK. It is asking the cross sectional area. What is the cross sectional area? 200 mm square. So enter the value as 200. Press OK. Then close this one. Now we have given the area of cross section. The next is the material properties. Go to material properties, material models, structural, linear, elastic, isotropic, 2E5, which is the Young's modulus for steel, and Poisson ratio 0.3. Then click OK. Close this one. The material properties are also given. Now we have to model this section. How we can model it? The dimensions are given. Now go to Modeling, Create Nodes in Active Coordinate System. Enter the node number as 1 and x, y coordinates are 0, 0. Press Apply. Now a node has been created at 0, 0. The next node has to be created at a distance 500 in x-axis. Is it? Yes. Then for that, enter the node number as 2 and x represents this box, y represents this box, z represents this box. Under x box, enter as 500, press OK. Another node has been created at a distance of 500 mm. The next node has to be created here. Now how to determine the coordinates? The total distance is 500 plus 500, 1000, which is the s coordinate, and the y coordinate distance also varies. It is 500. In which direction? In negative y direction. So we have to create node at a coordinates x 1000 and y minus 500. Is it? Yes, it's correct. So create a node number 3, x at a distance of 1000 and y minus 500. Press OK. We have got the 3 nodes. Now we have to link the nodes using the elements. How we can do it? Go to Elements, Auto Number, Through Nodes, select this node and this node, apply, and this node and this node, press OK. Hence, we have created the section what we have needed. Now the next condition is the boundary conditions. What are the boundary conditions? For boundary conditions, you have to jump from preprocessor to solution. Go to solution, define loads, apply. This end and this end are fixed as shown in the figure. This end and this end. In literal meaning, the node number 1 and 3 is fixed. Yes? Yes. For that, go to Structural, Displacement, on Nodes, select this node and this node, press OK. All degrees of freedom to 0. Hence, all degrees of freedom are arrested. That means the x movement, y movement, z movement, xy rotation, yz rotation, zx rotation are all arrested at the 2 points. Now the load has to be given at the node number 2. How we can do it? Go to force on nodes, select this node and press OK. We have to subject the load in y direction. For that, go to direction of force and select it as Fy, direction of force in y coordinate, y axis, and the force value is 12 newtons. Yes, 12 newtons. But when I give 12 newton, it indicates positive y, so the force will tend to pull this truss. But it is not necessary for me, because in the figure the force compresses the truss. The load is applied from top to bottom. For that, I have to give as minus 12. Press OK. Now the load is pulling downwards. If I give plus 12, the load pull upwards, which is not necessary in this case of problem. Okay. Yes. We have now given our boundary conditions. The next thing is solution. For that, go to solve, current ls, press OK. The solution is done successfully. If there is any error, it will be indicated in this box. Close this one, close. Now we have to review our result. How we can do it? For that, you have to jump from solution to general post processor, plot results, deformed shape, deformed plus undeformed. Press OK. Due to this load, this is the original truss structure. It is deflected to certain extent, as you can see. You can also visualize in 3D. How you can do it? Go to plot controls, style, size and shape, display of element on. Press OK. You can see the 3D element. I am changing to isometric view. This is the isometric view. This is the isometric view. Okay. Now we can also animate this one by using, go to plot controls, animate, deformed shape, deform plus undeform, press OK. As you can see here, due to the load, the truss structure is deflected likewise, which is shown in the animations. We can also find the stresses. For that, go to contour plot, nodal solutions, displacement vector sum, DOF solution for displacement vector sum, click OK, press OK. This is the displacement value. For stress, go to nodal solutions, stress, 1 versus stress. You can see the stress distributions. Deformed shape, choose this. Okay. We have successfully completed the truss analysis problem. Thanks for watching. Have a